So we're going to talk about desktop security. And in desktop security, we have a lot of things that in the traditional PC world, we haven't necessarily been able to address. Like, who would have thought about putting firewalls up between my PC and my coworker's PC in the past? Because it was physically a tough thing to do. And as we look at those things, we have a lot of things to discuss and talk about in regards to products. So one thing I got to put out there, disclaimer. If I say anything around a future product release, I'm not making any promises, so just keep that in the back of your mind. And please, no photos or tweets about anything I say is NDA. And as we talk about these desktop challenges, one of the things that we have is general data center security. As I start to look at my virtual desktop and I have users interacting with that desktop, I have them having access to different things within the data center. And we need to be able to put some controls around them. And we have some products from VMware, the vShield products, that give us the ability to put these controls on our end users' desktops to control what they're doing, which we weren't able necessarily to do in the past. And we're going to talk about the National Jewish Health Reference Architecture. They implemented something that Rob and I kind of talked about a couple years ago, and we've got a couple other customers that have done this and have deployed this to secure down their desktops and make sure they have less vulnerabilities in their arena. And then the last thing we'll talk about is how vShield 5 will improve your architecture, making sure that your environment is going to be secure and able to react to those day zero viruses. How many people worry about the announcement that comes out in the news about a day zero? Right? We all worry about that stuff, right? I remember several years ago when I was a desktop admin, one of the things that had happened to me, everybody remember SQL Slammer? Yeah, that was one of my wonderful nemesis. What had happened is I had went through and secured my environment. Boss called me. We read about this thing. I'm like, hey, no big deal. We're good to go. I'd protected my environment. What I wasn't able to protect was the user that was coming in that I had no control over. And what had happened is we'd had a contractor. Everybody have contractors in their arena? Yeah. Well, he had his own laptop. And I had told my boss that, look, we need to control laptop access. We can't just let a contractor come in and put their laptop on the network that isn't protected, et cetera, et cetera. And they said, Dave, you're overreacting. That's $2,000. The company doesn't want to spend that. We're paying the contractor to come in. It's no big deal. I said, okay, can you please send that to me in writing? And she refused to do that. But several months later, what had happened is he had got infected with SQL Slammer. Our environment, up until 9:47 in the morning, was safe and secure. Nothing was happening. At 9:47, I started to get alerts and phone calls, and things were going bad. And I'm looking into what's going on, and she's asking me, she's like, I thought you said we were safe. And I'm like, I know we're safe. I don't know what's going on. Let's dig into this. So me and the network admin started digging into it deeper to see what was going on, and we found we had a machine infected with SQL Slammer. So as we spent the next hour trying to locate this machine, we finally located it, disconnected it from the network, and we were fine. The point is I was forced to allow somebody to come in into an unprotected zone, and that person was able to take down our entire environment. Now, I still do have a piece of his laptop because the engineer I sent over to confiscate it accidentally dropped it down a flight of stairs 2 or 3 times. So he was very upset about me damaging his laptop, but I was more upset about the fact that he had ruined our environment. And how does VMware View allow me to address that? So as we start to look at some of the things that we're able to do is we're able to move the machine into the data center, okay? Not necessarily have it exposed to the external elements. I always worry when I plug my laptop into a customer's network what they may potentially give me, okay? I know my machine is clean and safe, but I don't know about your network or your network, and I'm always worried about what I may catch when I plug into somebody else's network. So I'm very, very cautious when I do that. With View, we're able to take advantage of some things like single image management, brought to us by Composer. And what single image management allows me to do is I can apply updates universally across many, many, many users. Imagine, put your desktop admin hat on, and imagine that I was your boss. And I'm going to use this gentleman up here because I kind of know him a little bit. And I was going to ask Jesse, I said, Jesse, by the end of today, we have 1,000 desktops in our environment, and I would like you to have Windows 7 Service Pack 1 deployed by 4 o'clock. And all you have at your demise is SMS or Altiris or whatever it may be, or Windows Update. Jesse, can you promise me that it will all be done by 4 o'clock? He hopes that disappointment is something I'm able to accept. Well, no, I don't like disappointment. So I'm going to get a little irate. And next thing you know, come around 2 o'clock, he's going to tell me, hey, I got 70% of my machines patched. Not good enough for me, because I'm really worried about what's going to happen. So next thing you know, we're going to send out the flying monkeys, right? Engineers that are going to go actually touch machines and figure out why they didn't patch. And hopefully by 4 o'clock, we're going to be somewhere around 80, 85%. But that's what I call the old spray and pray methodology. I spray it out there, I pray it takes effect before the bad stuff happens. And with View, we're able to change that. With Composer, I can take that master image that's assigned to 1,000 people, and I can patch it. And as I patch it, I get asked the question, Dave, when do you want this to take effect? And when I get asked that question, I can say, I can want it to take effect now. I can have it take effect at 3:55, so I guarantee it's done by 4 o'clock. And if I say take effect by 3:55, what will happen is throughout the day, as users log off, they will get a new image, and they will get that service pack, guaranteed 100%, no failures. And at 3:55, what will happen is all those users that didn't get the service pack will be forced to log out. And as we force them to log out, when they reconnect, then they will get the service pack, guaranteed 100%. So it changes our methodology on how we deploy that. And as we start to look about how we think about ThinApp, it gives me the ability to separate my application from the operating system, which is really, really important, because a lot of times we have vulnerabilities within an application that may come from the operating system, may come from the user coming to a particular DLL, executing their privileges, and moving further into the operating system. And by virtualizing that application, I can be admin inside the application, but nobody outside, normal user, which means I don't have to elevate my users' permissions and give them extra access to things. How many people have users within their environment that have admin level access on the local machine? It's not such a good thing. Makes you lose sleep at night. Where I lost most of my hair is admin access. So as we can reduce that access and control it within the bubble, anything that happens in that bubble is now an inert file. I can literally, with IE, ThinApp that, go browse some bad website, get a virus, and it's an inert file that ends up on my operating system in the sandbox. And I can do cool things with my IE, like have it delete the sandbox on exit. So that virus that is now an inert file doesn't have any access to the operating system and can't do anything. And as we start to look at endpoint, we can move virus protection from the operating system, where the bad guys can attack it, to the host, where they don't even know it exists. So they can't kill off the service, they can't execute privileges based off of the framework or anything like that. They're isolated, they don't even know it happens. And it's not post-execution, it's pre-execution. As we start to look at viruses come in through the vSphere host, we can actually grab them before the actual virtual machine is able to execute them. So it gives us a better pattern and a better ability to stop viruses. And as we talk about vShield app, this is our ability to put firewall rules around our desktop. Okay, being able to say, you know what, Jesse, I don't want you to be able to get to whitehouse.com because that's a bad site. I want you to be able to get to whitehouse.gov. And I can put a firewall rule up there that says block whitehouse.com. Or I can take this gentleman over here and say, I don't know what he's doing. I'm going to deny all. All he can do is get to the HR system. All right, so it gives us an ability to quickly and easily put in these rules around virtual desktops. And as we start to look at this infrastructure, the typical vSphere infrastructure is what we ride off of. There's nothing special about View. We don't use a special version of vSphere. We're just an interface into vSphere. And as we start to deploy into this, you'll see that there's many, many components to this. And one of them is the security server. And the security server allows us to connect that user to a machine in the data center and basically transfer a protocol, HTTP and 4172 PCOIP, into that virtual machine. And we can consolidate that coming from the outside so that users are able to come into the connection broker and get their desktop. And as we start to look at this, this gives us the ability to have that machine in the data center, protected by our corporate rules. I hope you all worry when your user goes to Starbucks and plugs into the internet with your laptop. That should be something we all worry about. And we should have rules in place that make sure that anything that happens while that user's outside our environment is protected against. So we have to be very, very careful. With a zero client or a virtual machine, There's no way for them to transpose something they caught at Starbucks into your environment, because all we're doing is sending back and forth screenshots to a machine. Their local laptop may be infected with something, but your virtual machine will not be infected. So as we start to move into how do we fix things, we got our firewalls there and all that wonderful stuff. Typical environment, I have a user coming in, and the green stuff's good, and I can block them and put access and all that wonderful things in and control what my user's doing. So from the far left, we have the user coming in from a zero client, thin client, laptop, whatever it may be, coming into their virtual machine. And they then have access to services on the back end, web browsers, CRM systems, SAP, whatever it may be that they're accessing on the back end. And today, we don't typically control what a user can get to, correct? We kind of give them free willy-nilly access to the internet and to the intranet or the network inside. Well, with View and vShield app, I can now start to block that. I can say, you know what, I don't want Jesse to be able to ping my desktop and probe at my ports and see what I'm doing and all that good stuff. So I can block him and isolate him from the rest of the world and only allow him access to the appropriate environments. With that, I'm going to turn it over to Rob and let Rob kind of talk a little deeper about what we're doing and talk about some of the physical security challenges, and then we're going to finish up with Liam.
And actually, I should probably retitle this slide. Physical security challenges is probably not the right term when you think of physical security. It's really more standard data center security challenges that we're going to talk about here. And what are the typical challenges that we see from a data center security perspective? And there's a bunch, right? One of the issues, again, when we start to move to this distributed model, years ago, right, when we started with mainframes, everything was centralized. When we move to this distributed model, it becomes very difficult to manage the security around these systems, around these desktops, around this access. One of the issues that we see is, and actually one of the interesting things is when you deal with desktops, you never see the concept of, we have server security zones that we put in place. We never see that concept for desktops. The reason being is they're all over the place. Even if they're all within our campus and they're actual physical desktops sitting on the actual desk, we very rarely see this concept, because what we end up needing to do is we've got these things spread out all over the place, so we have to create these VLANs, and we have to ensure that we're plugged into the right ports, and then we have to ensure that nothing else plugs into those ports. And there's a number of different things that we have to deal with, so it becomes very difficult. Port-based rules, again, very difficult to manage. When we try to put things like ACLs on our switches and those types of things, very difficult to manage. Agent-based solutions, so okay, let's get that protection down to the actual endpoint itself. When we try to do that with an agent, we have a number of issues. Number one, we have performance issues by putting all these different agents on there, right? The other issue is, how do you manage that? It doesn't scale, because each agent only knows about itself. And even if you put in place something like you have some sort of a central management console, it doesn't have full visibility to everything that's going on within that environment. It doesn't necessarily know where this machine is at any given time. And it's very difficult to start grouping those and managing those. So the scalability of that becomes extremely, extremely difficult. Again, when users connect remotely, how do we control where they go and what they can do? We've got some controls, but you can on the VPN, you can say, okay, when this user logs in, they can have access to this resource. But frankly, when they're logging in remotely, they need the same access typically that they have when they're sitting there at their desktop. As much as we'd like to really lock them down from remote, we really can't do that, because they need that same access. And the whole administrator rights issue, that's obviously a problem as well. Contractors coming in, like Dave talked about, a very difficult process, because we don't even manage those machines. So how do we deal with that? So the question is, what can we learn by what we do in the data center for our servers, and actually be able to apply that to our desktops to protect that data center and leverage those capabilities? So let's first talk about, how do we secure our data center, our servers in that back-end data center? What are the things that we do? We typically have this layered approach, right? We typically go and the whole concept of defense in depth, layered approach, whatever you want to call it, the point is that we have to put multiple layers up to make it difficult, to make it harder and harder for an attacker to get in. Okay, so they get past that first layer, well, they got to jump over another wall, and then another wall. And depending on how many layers you put in, the harder it is. It's also, you put too many layers in, it becomes impossible to manage too. So you need to kind of find that balance of where you're going to go. But the first step that everybody has is that perimeter security. We secure the perimeter of that data center. We put a shell around that data center. It's kind of that hard shell concept, right? That candy shell. You put that hard shell, keep the bad guys out. That's really the goal. The problem is, when you go to this distributed and mobile environment, we kind of lose that perimeter. So we'll talk about how, again, we can address that. The next step is that internal security. So for our servers, right, on inside, we create these server security zones, typically. So we've got a web zone, an app zone, a database zone for our multi-tier apps. We may have a zone for PCI data, right? So for CDE and non-CDE, we have to segment that off and protect that. We may have different zones for different types of applications. So maybe we have a separate zone for our HR and our finance applications or accounting apps, what have you. The point is that we need to separate these things out. I don't think a lot of people go to the full extent that they'd like to here because of the challenges that you have to put in place, that are there with the need to carve up our network, create a bunch of different VLANs, put these routing firewalls all over the place to segment this. I know a lot of folks that will set up a whole bunch of different VLANs, but in the end, all they have is routers in between those, and they did a great job of separating broadcast domains, which is actually what VLANs were designed for, and not for creating security zones. But they don't actually put the security between those because of the difficulty and not being able to manage that and scale that out. But anyway, this is kind of that next step. The last piece is the endpoint. Perfect example was Dave's, right? User comes in with their laptop. They went out to the internet. We've secured the core of our network, but that one endpoint gets compromised and it breaks all of that. Part of that's internal security. You need to put that internal security in place so it doesn't spread. But for a long time, our security was that hard shell soft center. But now we need to get to that endpoint. And this is typically agent-based approaches, AV, DLP type solutions, but these agent-based approaches that are going to protect at that endpoint. So if a user goes out and tries to download a malicious PDF, they don't get infected, or at least in theory, they don't get infected. And that's what we try to protect against with that endpoint. The problem is we get this concept of agent sprawl, right? We have agents all over the place, and it becomes very difficult to manage, not to mention the performance implications. So what we need to do is to be able to build these solutions right into the platform itself. When you look at typical data center security, you end up having physical infrastructure here that you have to dedicate to these. We end up carving up our networks, a bunch of different VLANs, like I mentioned earlier. They're very difficult to manage, very difficult to deal with. So again, what we need to be able to do is build this solution right into the platform itself. So as opposed to having all that physical infrastructure, we virtualize that. So let's do a quick overview on the vShield, and then we'll jump in, and Liam could talk about a specific use case and how he's leveraging these solutions. So I'm going to go over this fairly quickly. And I think a good amount of people have a good familiarity with this. If you don't and you want to get your hands dirty, I encourage you to go to the labs today. Labs 19 and 20, you can get your hands dirty with all of this technology. So vShield Edge, first step, right? Protect the perimeter. That's what vShield Edge is there for. Now the perimeter is a bit different. We're not talking about the perimeter of our physical data center. We're not going to say install a vShield Edge to replace your big iron type firewall that's sitting out there at the edge of your data center. But now our data centers become smaller when we move to this cloud model and this concept of virtual data centers. And that's what vShield Edge is really designed around, is to create that protection zone around those virtual data centers. It's essentially taking a physical firewall and virtualizing it. Same type of concepts there. vShield app, and this is really what Liam's going to talk about, is it's a much different concept. This is that concept of that endpoint-based firewall on the vNIC. It's in essence building a full stateful packet inspection firewall into your hardware, your virtual hardware, but into that hardware at every single vNIC. So not just at the VM, but every single vNIC. So theoretically, you could have different policies on each vNIC. The power to this is obviously that VM-to-VM traffic. That SQL Slammer issue that Dave was talking about, well, if he had this in place, and that user went to that virtual desktop, and we have this firewall rule that says no desktops can talk to each other, because frankly, desktops don't need to talk to each other, that never spreads. It's contained to him. Now, that user may have access to specific resources internally, but it will not infect the rest of the desktop. So you're not going to have this worm effect that Slammer did, right, and get out to everything because of the fact that he can't talk to everything. And there's no reason, again, for our desktops to talk to each other. We've got different tools now to share files, right? Reference was made in the keynote yesterday to this Project Octopus, right? This kind of Dropbox for the enterprise. That's how we should be sharing files. File servers and those types of things. We shouldn't be sharing our C drive out with anybody, put it that way. Sensitive data discovery, that's another key piece of vShield app where we can go out and scan all of our endpoints for regulated type data. So we've got 80 different regulations that we're going to cover, but basically we'll go out and look for HIPAA data, for example. We can look for PCI data in an unstructured format that may be out on a user's desktop. Very powerful from the fact that if we need to do an audit, we need to determine who's got what out there, and is somebody stealing credit card data, for example, and they copy them down to a spreadsheet and then take them home. We can gain knowledge of that and at least have that auditability to say, okay, this person has that, we're going to quarantine that system until we figure out what's going on or clean that up. vShield endpoint is that concept of offloading that antivirus. We haven't gotten to that point yet with Liam. We're looking at that. But basically, this is the ability to, like Dave kind of talked about, is to take that agent off of every single endpoint and run your AV scans from a security virtual machine on each of your hosts. Offloads it not only gives you that always on and that aspect of providing the protection from outside the context of where you're protecting, but it also gives you that capability of fixing some performance issues that we've seen with running all these AV agents on our endpoints. One of the issues we see, and especially we see this in a lot of federal implementations, is this issue of AV sprawl, when you've got a whole bunch of VMs going out and trying to run, or what we call AV storms, actually is a better term, when they go out and try to update their systems, right? They go out to get their signatures. Every single one absolutely kills the network at that time. And then when they go ahead and do their on-demand midnight scan, kills your storage overnight. Very often, these things never happen. And even throughout the day, because of the footprint, because of what they're trying to do, we see performance issues throughout the day. So by being able to remove this agent, putting that capability into a single security virtual machine on each of your hosts, it really takes all that performance burden off of the VMs and puts it on that one security virtual machine. We have vShield Manager that's going to go ahead and be your central management console for all of this, so you've got a nice UI to that. I think the more powerful piece of this is that it's fully API accessible, so we can automate this security. So say, for example, endpoint or data security, you go out and you scan your systems and you find PCI data on certain endpoints. Well, you can go ahead and automatically send a REST command to say, move this virtual machine to this specific security group and either quarantine it or at least put it there so I can go ahead and investigate it later and limit the access that might have. So there's some really interesting things we can do there. So again, I kind of talked about this. Some of the new things that are actually coming out in the vSphere 5 that I'll talk about, but vShield Edge, again, this routing type firewall. Some of the new things is now we've added the capability for static routing. We've also added, it's got an IPsec VPN, so we can actually have a site-to-site VPN with that. But one of the things we've added now is the certificate mode support. But basic stateful packet inspection firewall is what we're talking about here. And we move that in the virtual data center. And we can automate the deployment of that to create these boundaries around our virtual data centers. vShield app, again, we talked about this. It's that VNIC level firewall. I kind of already covered this in pretty good depth, so I'm not going to go too deep into it. But there's some new features that I'm actually going to talk about later. After Liam gets up and kind of talks about what he's doing, we're going to talk about how the new version, the vShield app 5, when that's released, how that can help us and how that can actually make the use case even easier for what Liam was able to do. Again, data security, we covered this. Basically, that ability to go out and scan all of your VMs and look for that sensitive data, that regulated data, and go ahead and potentially quarantine those systems automatically, but at the very least, give you that visibility that you need. EPSec 2.0, there's some enhancements to that as well, so the endpoint security piece, so the ability to actually have multiple security VMs that are actually leveraging this is a really key feature here. There's some integrations now with the different product sets as well. So, lastly, we kind of mentioned security zones earlier. What do we typically use those for? We use those to separate our systems, right? We create these security zones to ensure that if somebody, for example, gets to my app zone, right, somebody has compromised an app server, that they can't get all the way to that database server directly, that they have to jump through these hoops. And that's why we create these multi-tier apps. I mean, we have the multi-tier, I should say, that's why we create the zones around each of the layers of the multi-tier app, or each of the tiers of this multi-tier app, is the ability to provide those zones around those. But how do we use that and apply that to the desktop? What does this have to do with desktops? How can we apply that? And again, we can create this concept of desktop security zones. Now, as opposed to users being distributed all over the place, when they get to their virtual desktop, it can automatically be put in a very specific security zone. Based on objects that we've got from View and vSphere, we can very easily create these zones. So we can have user A, when they log in, or say, the doctors, when they log in, they have access to medical servers, for example, medical applications. Hospital administrators, when they log in, they only have access to billing systems, for example. But the key thing is now we can very easily, based on their user, right? So when you log into View, you get access to your specific desktop pool. When you access that desktop, we will have vShield app rules logically zoned, so all on one big network, but logically zoned out, so they can only access very specific resources. So I'm going to go ahead and pass off to Liam right now, and he's going to talk about his specific use case, how he was able to implement this, and the challenges, and as well as the benefits that he was able to gain from this. So,
thank you very much, Rob. I
no problem.
Appreciate the intro. My name is Liam Schneider. I'm from Denver, Colorado, and I'm going to tell you about what we've done at National Jewish Health to kind of help secure our desktop infrastructure in our clinical environment. So this is the use case overview of what we're trying to do. We essentially have a couple different users that we're targeting for our first implementation, and they are our clinical users and our doctors, physicians. And we've got persistent and non-persistent desktops. So if a particular user needs to have access to the internet, we give them a particular persistent desktop and they can customize that. Non-persistent users do not have the need to have that. They're more task-based workers. I've implemented a single sign-on solution from Microsoft called Centillion. This allows the doctors and clinicians to quickly access their applications. And along with that, it has what's called single patient selection, so that if one doctor is opening up a particular patient, they'll be able to open that patient on all the other applications that they have open, such as radiology, their electronic health record. It will open that same patient automatically so that they can save some time. And also, this reduces the chance that somebody could chart in the wrong patient record. So I've also allowed the use of the badge readers to help identify who they are. The doctors hate clicking. Doctors hate typing anything in. So we're trying to help alleviate some of that pressure by using badge readers to identify them. If in the future, we'll go with some fingerprint readers along with that to act as their password, so that we can still have that. We still have that two-factor authentication right now, so they have to type in their password today. But along with this, I wanted to just make note that I do allow a particular grace period for these badge readers. It's a very short amount of time. I think it's about 10 minutes at the moment, and that's always an ongoing debate as to how long I want to have this grace period. What the grace period allows us to do is if the doctor's logged into one particular workstation and they're roaming to another area in the hospital, they can just tap their badge and they don't have to put in their password again. But when that grace period expires, they have to go ahead and type in that password again. I'm roaming the desktop session so that they can have some application continuity. They can, if they open up Word and they're documenting something in Word and they've opened up their electronic health record and they've got a particular patient open, when they go from workstation A to workstation B, the same information is still open. There's no change in their desktop experience as they go from workstation to workstation. Again, going back to doctors need to have quick access to all their information, or else they start giving me a call and things get really hairy real quick. So I also use ThinApp. I haven't been able to virtualize absolutely every application, but I'm working with the ThinApp specialist to get all of those applications that it can virtualize, so that, as Dave was talking about in his example, if you wanted to upgrade the operating system by 4 o'clock in the afternoon, I'd be able to do that without affecting any of the applications on it because they're all virtualized. I'm using group policy from Active Directory to redirect all of the user data, home directory, my documents, desktop, all the stuff that typically the users would want to customize so they can have their picture of their kids or whatever on their desktop. And at the end of the day, if they're using a non-persistent desktop and it refreshes, when they log in, all that customization comes right back. So I've got 2 use cases. First use case, I'm calling the light clinical users. These are the more task-based workers. They open up the EHR, they open up radiology, and that's really all they do all day long. The OS disk gets refreshed as soon as they log out. I'm also allowing USB redirect. National Jewish is a pulmonary institution. If you don't know that, that's one of their bread and butter. They do a lot of other things, radiology, oncology, but they've made their mark as being the #1 respiratory hospital in the country, perhaps the world. So they need to have access to do PFTs. So I had to have a USB device run through to the desktop into these clinical areas. I also allow multimedia redirect on these particular desktops. Patients come in with information all the time. They need to be able to access that information quickly and easily. I allow them access to specific websites, not the whole internet. There's no reason for a doctor or a nurse to be able to, surf to whitehouse.com while they're in the patient's room. And this is deployed mostly in clinical areas. My second use case is what I call the heavy clinical users. They have a dedicated assignment, just like my first use case. All the customizations are saved. They are. I've got periodic snapshots for quick recovery. If a particular user decides to load a widget, like WeatherBug or something like that, and they mess up their entire desktop because they get spyware or malware, I can go back a week, recover that snapshot, they're good to go. I don't need USB redirect here yet, so I don't allow that, and they don't need any multimedia redirect. They can access any website. They are deployed in mostly physician offices and any clinical manager offices. So here's my vCenter layout. I don't know if you can read that, but I've got my clinical desktop systems inside this particular pool. I've got my persistent desktop systems inside that pool. Here's all of my vShield firewalls that get deployed when you deploy vShield Manager. My connection broker. Can't think of anything else to talk about on that slide. Here's my Active Directory groups. This group here gives access to my non-persistent desktop system, which we call the clinical desktop system. And then here is how I give access to our persistent desktop users. So let's get right into the firewall rules that I've got in place with vShield vApp. This is the general network rules that allow access to the network time protocol, the NetBIOS for communicating with all the domain controllers. These here are all the rules that allow Active Directory to be communicated with on the workstations. Yes. This is not the whole list. I'll get to the other part. Here is the rules for allowing the View agents to communicate. 4172. I allow RDP. I don't know why yet. I just left it open. I'm probably going to end up closing it off because There's no reason for me to allow that access right now. Here's where I allow USB and multimedia redirect with those ports, and then the View Manager port. Here's my applications. This is where things got kind of complicated. I had to figure out how every single one of these applications talked. I started with Symantec. For some reason, Symantec doesn't allow me to use endpoint, so I end up having to use just your standard Symantec endpoint protection port to talk with it traditionally. I've got file servers, so here's my file servers that I'm allowing people to have access to. I've got my EMR server. I've got my hospital information system, and this is where I've got my Centillion software, my single sign-on, single patient selection software, allowing access into the VMs, my radiology system, my scheduling system. Here's where I allow access to the Exchange sites for these persistent desktops. The Exchange server, I've got my clinical desktop here allowing access to only some sites like OA, the intranet. I don't allow regular Outlook on the non-persistent desktops. Here's my deny, right at the end, for everything. That's basically what I've got today. We're definitely going to be improving that, but I'm going to go ahead and turn it back over to Rob to talk about the rest of this.
All right, so thanks, Liam. That was great. So what I'm going to talk about real quickly here, let me actually take this from you here, is how can we improve with vShield 5? So I don't know if you noticed, I'm going to pop back here a little bit. A lot of rules. Lots of rule sets that we're dealing with. I mean, look at this one for Windows. I mean, just to get Active Directory to work, we have to open all these ports, right? We've got the different domain controllers as well. So you've got domain controller 1, domain controller 2, 3. We've got a whole bunch of rules here. It's nice, though, that we can actually choose these and choose these by objects, right? So we don't necessarily have to go ahead and create IP-based rules. We don't have to carve our network up. You know, these clinical desktop beta, the persistent desktops, these are groups, these are actual groupings, but these are resource pools within vCenter based on the desktop pools that are created within View. Again, you got your different file servers, all these different components, but the nice thing is the way we can actually group these and leverage the objects that we've got within vSphere to actually create these rule sets. The problem is we still have to have a whole bunch of rules because we don't have any additional levels of grouping in vShield 1.0 and vShield app 1.0. So that's where vShield 5 actually can help, is we've got some new capabilities to actually start grouping these down. So again, here's this long rule set. So how many rules do we have here? What does it tell us here? 27 rules, right?
Something like that, yeah.
We can actually knock these down to 3 rules with some of the new capabilities in vShield app. And again, you can take a look at this. If you go check out the lab, it's lab 19 in the hands-on labs, you can see how we can do this. But basically what we can do here, where's that laser pointer?
Yeah.
There we go. What we can do here is we can take a rule for each of these. We can create a grouping for all our domain controllers. So as opposed to having domain controller 1, 2, and 3 here, we can create a single group for the domain controllers. And then what we can do, and I think these, are your domain controllers physical, Liam? They're physical systems? Mm-hmm. Okay, so for these physical systems, what we can do is actually have an IP-based group and put those together. So we can know about these physical systems and then create that grouping and say, and have a single rule then for all of these. Actually, one rule for TCP and one rule for the UDP apps. And then one, any, for these broadcast traffic. Now, we may actually want to tighten these down a little bit more as well, again, to not necessarily...
Some jackhammering going on next door.
Construction work, don't anybody work?
Yeah, I was like, what's going on here? So, but basically, we can take these and knock these down from, again, the 27 rules to 3. How about the rules here for these vCenter objects? You know, one of the things here you notice is we have a separate rule set for our clinical desktops, our persistent desktops, for just the View sessions. Sure be nice if we can just have one rule, you know, a grouping of these different types of desktops. One of the limitations within vShield app 1.0 is the fact that you couldn't do a parent and child resource pool. So if you had a parent It didn't matter what the children resource pools were. You would have to choose each individual child resource pool to create these rules, which is why we did this. With vShield App 5, what we can do now is say desktops. And then under that, we have clinical desktops, and we have our persistent desktops, and the different desktop rules. We can group those together and use the parent resource pool to create the rules as opposed to the individual. Question?
Can't wait.
Next question.
Almost to a template basis.
Yeah,
and
actually
nesting templates also.
Yeah.
And as we move into the View next release, you will see where we will automate some of the check boxes so that you can select this stuff and not have to necessarily go and talk to your vSphere specialist or your network specialist. You'll have pre-populated templates, and you can say, hey, I want to give the general access rule. And then, Jesse's misbehaving, and I want to give him the nothing access rule. So I can isolate him down and take care of it.
Yeah, and actually going back to this slide, that's a good point. I forgot to mention that. We can take all these Windows rules and create a Windows grouping application, and it can put all these different protocols that are required for Windows and actually two, because we can do it for TCP and then UDP. So we'd have two groupings of those applications. Excellent question. Layer 2 firewalling. One of the new things with vShield App 5 is we can actually not only do Layer 3, because we're on the vNIC, and we know MAC address, we know that core, what vNIC goes with what VM, we can actually do Layer 2, so broadcast containment. We can prevent, at a Layer 2 level, from these VMs in the same desktop zone, for example, from sending ARP requests to each other. So number one, we're going to cut down on the network traffic and cut down those broadcasts, but number two, then we truly make these desktops between each other invisible to each other without having to carve our network up into a whole bunch of different zones. So these groups that we use, we can actually create Layer 2 boundaries around those and prevent those from talking to each other as well. This was an issue, actually, one of our customers, they deployed at one big flat network. Well, remember, we created VLANs not for security, but we created them to contain broadcast domains, but they didn't want to deal with the headache of VLANs. But what then that they happened, they started seeing broadcast storms. So we built this capability so now they don't have to deal with those broadcast storms. And not to mention, it adds another layer of security because you can't even go out there on Layer 2 and discover other services running, other systems running out there.
Yeah, this is great because I've only got a Class B for my entire View desktop, so this is actually perfect.
Yeah, so this will help you when we go ahead and implement this.
Absolutely.
What else can we do here? And these are things that we didn't even really talk about, but we can leverage Edge and App for actually protection of the View server, the View components, our management components. Now that vShield Edge can actually do routing and not NAT, we can use it in a much cleaner method to go ahead to actually protect our management network with vShield App and our management systems. We can also, again, vShield Endpoint we really didn't even talk about. Liam mentioned that Symantec today doesn't have a solution, but we're talking and we're looking with our other partners potentially at what they can do for him from a offloaded AV perspective.
Yeah, they tell me they're coming up with something.
Okay, good.
We'll see.
That's good. And then the data security. We didn't even talk about that. I mean, this is a healthcare organization. They have to deal with HIPAA. Actually have to deal with PCI as well.
Absolutely.
You're taking credit cards.
Absolutely.
So this is a great way to go out and scan those systems. And again, these are things that we still have yet to explore within his use case, but we're working on that with him. So I want to open it up for questions. Hopefully most of the questions should go to Liam, because I think it'd be the most interesting.
I'm going to ask the first question.
Okay.
So I haven't met Liam in a long time since he did this. And my first question is most vSphere admins are very good at server hardware and virtualization. And as we start to get into desktops, it's a new group coming in. And I would not consider myself a network admin, okay? And when I say network, I call Rob all the time. Hey, how do you get from IP address to here to there and all that good stuff? And he's like, Dave, you're killing me. It's not that hard. And so as I consider this, I would not consider myself a firewall rules expert. Would you consider yourself a firewall rules expert?
Over the course of time, having challenges, I've gotten a lot better, but no. I hired a network engineer to be that expert.
Gotcha. And did that network engineer implement this for you, or did you implement it based off your knowledge as an admin?
I implemented it, definitely.
So the point that I'm trying to get to is Liam is a smart guy. He's not a smart network guy, okay? He's a smart guy. And as we start to look at this network rules, sometimes it's a little overwhelming. you're like, holy cow, I'm just a desktop guy and I got to go do this. It's not that hard. We have simplified it to a point where I wouldn't have to call Rob. I actually, when we got prepared to do this, I've talked about this with customers, and I have customers doing this also in the government space. And as we got prepared for this, I said, you know what? I'm going to do an experiment at home. I love to experiment on my child. He's 16 years old, okay? He has some issues now because of some of my experiments. So what I did is I took our virtual desktops and I secured them down. And I told him the only thing you can get to is the school webpage, Google, and some other encyclopedia site. He cried because he couldn't get past it, okay?
It's tough seeing a 16-year-old cry.
Yes, it's tough seeing a 16-year-old cry. But the point was, is in a matter of about 3 hours, I had this all set up and running. And I don't consider myself a network admin, okay? Consider myself a virtualization guy. So when we think about that, it's very simple to implement. So I'm going to open up to the next question. Hopefully that's giving you guys.
Before you go on, I mean, when you were just talking about that, you know, one of the challenges I had was coming up with all the ports that were needed to get to every one of my applications, including the Windows network. You know, what Rob here was talking about was the fact that now is even becoming easier. So you don't need to have, you even have to be, you can be dumber.
Fair enough. Yeah, actually,
for lack of a better term.
Did you use the flow monitoring piece for that?
I did use the flow monitoring piece.
Yeah, so there's another capability we didn't even talk about that we give full visibility in vShield app to all the different traffic going on. So when you're creating these rules and as you're building this out, if you see traffic being blocked and your windows aren't working, you know, the Windows sessions aren't working, you're able to go back in, I missed the port, and add that in. And as a matter of fact, you can click a button and have it automatically added.
Your blog has a great reference for that up on VMware's blog.
So other questions out in the crowd?
Yeah, and please step up to the mic so we can, everybody can hear and get you on the recording.
Wherever you are.
On the data discovery piece, how come I've got several different development groups who actually play with several different kinds of data that aren't necessarily going to be canned very easily?
Right.
Is that something I can import a template in because I've got groups that love to bring live data in and I don't like to let them?
Not today. That's the work we're doing with RSA actually. So they're the core engine within our data discovery piece. And longer term, you'll be able to hook in their full solution to that.
Can you talk a little bit about the density that the AV scanning offload? So I'm assuming you got some sort of app that runs on a host. How dense does that get? So like one app for 10, 20 VMs? I'm just curious what the density is.
Yeah. So it's the app. It's basically you have a virtual appliance that runs on the host. It's designed to scale with however dense you can have whatever density you can put on your host. Now, as you start to get to 200 and 300 desktops on a single blade, you're probably going to have to expand, the memory and the CPU of that virtual appliance. But by default, I think it comes, and again, it depends on the vendor, right? So, but vShield app is the one that's shipping today, or excuse me, vShield app. The Trend Micro is a solution that's shipping today, and I believe shipping today, and I think the specs on that are 2 gig of memory and 2 vCPUs, and it's a 64-bit virtual appliance. But you can expand that as needed. So it's really just a matter of expanding the resources that has so it can keep up with the amount.
Generally in the desktop arena, what I have seen is if you look at what just antivirus is, there's a 20% hit. And once you implement and offload to the host, we see a 2% hit.
Right. Yeah, one of the things you're doing.
It's really significant, the offloading of that, how effective it is. Because now we don't have, conflicting virus scans and all that other stuff happening at every individual host.
I can attest
it's happening scheduled.
Yeah, and not to mention you're able to take that agent that's 100, 120, 130 meg on each of your VMs and take that memory back. And now you've got a thin kernel driver that still runs on the VM, so you do have to have one component still there, but it's about 5 to 10 meg, and you can take all that memory back and actually either expand out, have a better consolidation, or actually just give that to your security VM if needed.
Not to ask any secrets, are there plans to bring other vendors to the table aside from Trend Micro?
Oh yeah, I mean it's wide open actually, and as a matter of fact, go out to the floor. You can go. I think the McAfee booth, they've got something now that they're showing. I think Kaspersky, Sophos. It's what we've got. I think
it's an open API framework.
It's an open API for ISVs, so for security ISVs, and so with a specific project in mind. So I think there's about 12 vendors out there today that are actually working on solutions for this.
Awesome.
So, so it's not just Trend.
Appreciate it.
Morning.
Morning.
Our organization, we don't have View installed. We're just getting into virtualization for the last year and a half. So right now, our workstations are ready for a refresh after 6 years. We're all XP. And the more I listen to this, especially today, you guys are getting into this to vShield Edge, App, Edge Point. Is there any real need for AV, really, after you start locking down these virtual desktops and zoning them out?
Good question. So for mobile users, yeah, you still need it for mobile use. Well, and again, it depends. If they need to take their laptop and be offline.
I mean, if they're link clones where
Right.
they're just logging off and, you know.
Oh, that's a whole nother debate, right? So whether you even need AV at all in that case, yeah, because the way we can contain things, that's actual good debate. I mean,
I asked myself the same question when I was trying to figure out non-persistence versus persistence, and it was one of the big reasons why I went non-persistent. Was I could offload all of the customizations and redirect everything and know that every day their desktop would be pristine and clean because it was going off of that link clone technology. But the idea of a zero-day attack frightens me. It's something that could keep me up at night. I have been hit by a zero-day attack, and it took down a significant amount of the hospital network. So,
And you said you had persistent or non-persistent?
I have both, but my prevalent system is non-persistent. I only give persistence. You know, that's something that's special. If you really need it, if a doctor's really wanting that for whatever reason, I got to give a business case before I'm going to deploy that.
Do you use any type of surf monitoring? I know we do also. We use WebSense. We're looking at something else now, but any.
I have I've got a web filter. I use Palo Alto, their web filter, on the edge. I've got the other standard monitoring tools for the AV, so I can see into that. I've got other monitoring tools in place. Is there anything specific you were looking for?
No, I mean the only other thing is if someone brings something onto your network, if they bring in an outside device, connect in, or else someone on the inside connects out via
the key
the
thing
web
is,
and hits a web page that they don't know is affected.
That web filter really helps out quite a bit. Yeah. We want to do network access controls as well.
I would be willing to say in a theoretical world, you could probably tie down a machine to a point that you could say, for the most part, I'm safe. Okay, and knowing that you can, delete the machine and recompose it, that'd be a very interesting approach. Would I want to put my career on it? No way, because there's too many things out there, and you got to have that layered, in-depth approach to security. Mm-hmm. If you have, the firewall rules, and you have vShield Edge and vShield Zones and vShield App running, and you're recomposing your machine, your risk, as you add all those layers, your risk starts to go down even further. Right. Not one of them's perfect, right? I mean, SQL Slammer wouldn't have happened to most of us if all the tools were perfect. And that was basically a denial of service attack is all it really was. Amazing what one machine can do to a network. Yeah, and so that's kind of my thoughts on that.
Right. And actually, the example you gave is a perfect reason for something like the non-persistent desktops, because even if it does get infected, you blow them away. And if somebody comes in, you don't allow another machine to get onto your network, would be the key. And if they do come in, you basically need to just provision them, and maybe even a guest user desktop, a guest desktop that would have the proper access, but have it siloed off to the point where they can't get to very critical systems. Not to mention, even if they go out and get compromised, that machine can't propagate it because of using that VNIC level firewall, the vShield app, because it can't talk to anything else within the environment. It can literally be isolated from everything else. So using this defense in depth with the endpoint, with the app, all these different components, along with the capabilities of View to be non-persistent and bring those up, but the persistent profiles, all those together are really good. Yeah, there is always a debate: do I need AV? Do I not need AV? Depends. It really depends on how often you're refreshing those, because there is that time that's in there.
Hi, Rob. I was just wondering if as you start to implement all these tightened down controls, what's the effect ultimately on the Windows browser? The Windows Browse master elections, and if I'm the user and I'm opening up my network neighborhood, what's the difference that I'm seeing now?
Well, so NetBIOS communication that you saw, I did open up, so that particular communication still occurs normally, just like any other Microsoft network.
But if I'm in a zone, do I see all the other nodes on the network communicating, or do I just see?
If you zone and you
Yeah.
put the proper rules in place, you won't.
Okay.
Right.
And it depends. Now you'll need to let them see
Right.
the domain controllers and those types of things. But again, the desktops don't need to see each other.
And that's pretty much all I see is my file servers and my domain controller and anything else that I'm allowing in that particular zone.
Right. I would just ask that maybe in future incarnations of your presentation, I think it'd be kind of nice to show something like that, just to show or to articulate, this is what happens, now the user,
This is what
this is what the user could see before we
Yeah.
implemented zones, this is what he sees now.
Good idea.
I think it'd be good for me to be able to show something like that to my customers to say, I can make sure that you're quarantined in your own private little world.
Yeah,
Absolutely.
go
Absolutely.
check out Lab 19,
Lab 19.
and you can see it.
Any other questions?
All right.
Thank you
I
very
have
much.
a question. How many people see this as something viable in their environments? Who wants to go do the lab? Everybody needs to go do labs, right? Labs are the best part of VMworld.
Yeah.
It's true.
So thank you very much. If there's any questions, we'll be around here for a few more minutes, and have a wonderful day.
Take care.